Colleagues, I am back. I am back. I have highlighted the item previously, so we are going to dissect it. We start with the category of the nature and type of bonding. So we said that sodium chloride is undergoing, it's an ionic compound. Therefore, the nature and type. Here they did not want the category of the compound. No, they did not want the category of the compound. They said nature and the type of bonding in each nature and type of bonding. So what is the correct response? Sodium chloride undergoes ionic bonding. Then you explain, you give a reason. Undergoes ionic bonding. Recall from my previous lectures. Now, if you are watching this for the first time, I'll refer you to the previous sessions. Previously, we said that for ionic bonding, a metal transfers electrons to a non-metal. So it is undergoing ionic bonding because sodium transfers electrons to chlorine to form an ionic bond. Undergoes ionic bonding, which involves transfer of electrons from sodium to chlorine to form an ionic bond. Alternatively, one can also say that because ionic bonding gives rise to the giant ionic structure. If you recall from my previous illustration, I have demonstrated the giant ionic structure for very many times. Maybe for those of you who are joining us for the first time, this is how it looks like. Let me demonstrate it to you. This is the giant ionic structure. You have ions that are, for example, there is an ion there in green and another one in black. You have ions that are held together by an ionic bond. Therefore, for that note, one can also say that, where is my thing here? One can also say that, sodium chloride undergoes ionic bonding, which involves electrostatic attraction. In that structure, we are having attraction between positive ions and negative ions. That attraction is that line there. The line which joins the positive to the negative is the attraction. So sodium chloride undergoes ionic bonding, which involves electrostatic attraction between sodium and chloride ions to form an ionic bond. Then the other substance, am I on? I'm on. The other substance was aluminium. Aluminium undergoes metallic bonding. For metallic bonding, colleagues, let me remind you, for those of you who are joining us for the first time, metallic bonding is this type of bonding. It is here. I think I have removed it. It is here. Where are you, metallic bonding? Metallic bonding. Metallic bonding, that's how it looks like. In metallic bonding, you have metal ions which are surrounded by electrons, like that. So therefore, for that case, what is our response? Aluminium undergoes metallic bonding. Why? Aluminium undergoes metallic bonding. Why? Undergoes metallic bonding because within that type of bonding, we have electrostatic attraction between aluminium ions and the delocalized electrons to form a metallic bond. Metallic bonding, which involves electrostatic attraction between aluminium ions and delocalized electrons to form a metallic bond. Then carbon dioxide undergoes covalent bonding because it is made up of atoms of nonmetals. So it undergoes covalent bonding, which involves, for covalent bonding, still, if you are watching this for the first time, I'll refer you. If you are watching this for the first time, I'll refer you to the previous sessions where we have explored the covalent bonding. How is it formed? Covalent bonding is formed by sharing of electrons. So undergoes covalent bonding, which involves sharing of electrons between carbon and oxygen atoms, to form what? To form covalent bonds. Of sharing of electrons between carbon and oxygen atoms to form covalent bonds. So that is part A. Then part B, what did they want for part B? Part B is here. Part B, they wanted the properties. Where is my part B? It is here. Explain, you see, explain two properties of each substance. You explain two properties of sodium chloride, you explain two properties of carbon dioxide, you explain two properties of aluminium. I have explained those properties, colleagues, for the previous videos. If you are watching this for the first time, can you refer to those videos? I have explained properties of ionic compounds. I have explained properties of covalent compounds. I have explained properties of metals. Therefore, and here for part B, I'm going to be very quick. Part B, we use, don't forget that thing, state, solubility, structure, melting, conduction, density. We use those statements to recall those properties. You can comment on state of a substance, solubility of a substance, structure of a substance, melting point of a substance, where the substance conducts electricity, its density. I repeat, we use science, solve structures man cannot do, to help us memorize those properties of substances. Like science stands for state. You can comment on the state of a substance. Solve stands for solubility. You can comment on how the substance dissolves in water. Structure stands for the structure of a substance. Is it giant metallic, giant covalent, simple molecular? Man stands for melting point of a substance. Cannot, conduction, do, density. And I have explained this thing previously. So allow me rush through this. If you are watching this for the first time, I have explained. Kindly review or revisit the previous videos. We gave these properties for, do you recall, for potassium chloride? We gave those properties for potassium chloride. And they are the same. They are the same. They are the same. Then use, it is also used as a preservative, as a fertilizer. Those are the same use. These are the same uses which we gave for potassium chloride. They were the same uses. Dangers, I explained that very well. I took a very long period of time to explain salinization, changing water pH, temperature, all those points. See, they are there, non-biodegradable. I've explained that. Then the other substance still for aluminium. Aluminium, now we have also looked at it in the previous item. It is there. Maybe for carbon dioxide. Aluminium, we have looked at it previously. Those are its uses. Allow me finalize. Those are the dangers. Finalize with carbon dioxide. Now for the previous item, carbon dioxide was not there. And colleagues, I want to say that even though carbon dioxide was not there, still we can use the properties of methane. We can use properties of methane to formulate properties of carbon dioxide. State, carbon dioxide exists as a gas at room temperature. Why? You recall the reason which we gave for methane? It is the same reason here. Due to presence of weak intermolecular forces of attraction, it is the same reason. Then for methane, we said that it is insoluble in water. Same thing here. It is slightly soluble in water, but soluble, highly soluble in non-polar solvents. Colleagues, previously I mentioned why covalent compounds like methane, carbon dioxide, I mentioned why they are soluble in non-polar solvents. If you are watching this for the first time, kindly refer to the previous videos. Because it is made up of non-polar bonds, simple molecular structure, we also looked at that. Has a low boiling point, we also looked at that for methane. However, there are others. Does not conduct electricity because it is not having charged particles, has a low density. All these points were given for methane. You see how things are easy. You people just decide to fail. I also don't know why you keep on failing. Which other property? Now you can also think about chemical properties. Carbon dioxide is an acidic oxide which turns blue litmus paper red. That is a chemical property. Should I repeat it? Carbon dioxide is an acidic compound. Carbon dioxide is an acidic oxide. Carbon dioxide is an acidic oxide. Carbon dioxide is an acidic oxide which turns blue litmus paper red. Another one. Carbon dioxide turns lime water milky. Or carbon dioxide reacts with calcium hydroxide solution to form a white precipitate. All those are chemical properties. So you can give physical properties or chemical properties. Dangers, still carbon dioxide uses. Okay, before the uses. Now, the most important use of, or the widely applicable use of carbon dioxide, in fact, there are two. It is used in fire extinguishers and also in fizzy drinks, sodas. Do you know why it is used in fire extinguishers? Now, if you have ever pressed that fire extinguisher, the fire extinguisher will give out carbon dioxide, which will form a blanket. If you have ever used the fire extinguisher at school, if you press it, it forms a blanket which does not support burning. So it is widely used as a constituent of fire extinguishers to extinguish burning flames. Why? Because it forms a blanket that does not support burning. Then other uses, it is used as a preservative in fizzy drinks. Why? Carbon dioxide does not support activity of bacterial microorganisms. It doesn't. Gases like oxygen supports the work of bacterial microorganisms because we have bacterial microorganisms that are aerobic, which need oxygen. However, those that need the oxygen, now if carbon dioxide is present, now they will die because the gas which supports their life is not there. We have carbon dioxide, which is acidic, therefore it does not support their activity. Photosynthesis in plants, you can also think about that. Dangers, carbon dioxide can be linked to global warming. Yeah, we saw that. So colleagues, allow me stop here. Allow me stop this here. And I thank you for listening.